Hi, my name is Taylor Toby. I'm an OpenSciEd teacher and facilitator, and I'm here to discuss with you Lesson 12 of the 8.4 unit Earth and Space. Congratulations, you and your students have reached the end of the lesson set 3, Bend about light and color. You should be very proud of yourselves. You've done a lot of work, and I hope your students are really intrigued by the transfer task at the end of this lesson. So, how did we get here? Students just figured out that light interacts with water and glass of certain shapes and angles to produce a rainbow, and that these different colors end up less bright than the original white light. And we can also recombine them to create that bright white light. And even though after it changes its path and refracts into those different colors, the light still continues in a straight path. There's a lot that we figured out in Lesson 11. So let's take a closer look at Lesson 12. It's a putting the pieces together lesson. It's 2 days. It only takes about 5 to 10 minutes of prep time. This is because it's not a hands-on investigation, but it will require devices. In the first day of this lesson, after revisiting all of our models from previous lessons, students figure out that white light passes through Earth's atmosphere and refracts. So less light is reaching the moon's surface, but there's still some so we can see it. And as this is happening, blue light is scattered more than the red, which is why the moon appeared red during the lunar eclipse. In the second day, students are applying everything they've figured out from this lesson set to a new scenario all about fishing. Students will look at colors underwater and the position of fish underwater and explain why we see changes to both. What students will figure out in this lesson is that fishing lures are made of specific colors that transmit better through water at different depths so that they are more visible to fish that are living at those depths. And they'll figure out that a fish appears in a different position underwater than where it actually is. That's because the light is refracting as it hits the water and then travels back to our eyes. Some key moments in Lesson 12. So for part 3 and 4, students are constructing a model of a lunar eclipse in small groups, and then we come together as a class. You're going to start looking at all of the models that you've made, starting with Lesson 7. I highly recommend leaning heavily on progress trackers and all of those different models that you've made. And then when you're revisiting those models and filling out that note page, have students include example drawings to refer back to as you're trying to pull out what you need to explain what's happening during a lunar eclipse. As you can see in this image here, it is very complicated and there's a lot going on. So having those smaller models to refer back to and add in will be very helpful so students don't feel so overwhelmed trying to recreate it all themselves. And then in part 7, for this transfer task, have a clear plan of evaluating student work beforehand. I highly recommend looking through all of the assessment materials in the Google Drive well in advance before having students complete this assessment. And be mindful of students with visual impairments, whether that be color blindness or something else, since this requires students to have direct observation about changes in color or brightness. You can have closed captions on or like text boxes explaining how those marker caps look as they go deeper and deeper underwater. Another thing to keep in mind, that the printer quality and the brightness of your projector in the room really, really influences the images in color for these reference materials. So you'll want to do a trial run of this to see what everything looks like and make sure those images appear as you intend them to. So where do we go from here? We realize we've figured out a lot about light and its interactions with matter. So it's time for us to head back to the driving question board to figure out if we have any more unanswered questions. Hopefully we have lots of questions about other objects in the solar system, and then that's where we'll want to guide students to next. Some material management tips and tricks. So, posters for this lesson. You will be referring back to all of your consensus models from lessons 7 to 11. And during this lesson, you'll be creating quite a few posters. You'll have your lunar eclipse revision modeling. You'll have your class consensus model of why the moon changes color. And you'll have an anchor chart about color changing at different depths for those marker caps. Thank you so much for joining me about Lesson 12. I hope your students and you feel a great sense of accomplishment for how far you've gotten. We're in the last bed now, and I hope to see you in Lesson 13.